All right, so welcome to class, everybody. On the left here, we have a circle. We're going to talk about circles today as well as CPCTC. This is 3.3 in your textbook. So here we have a circle. We can name circles by their center. If I tell you that D is the center, so let's say I'm telling you this, D is definitely the center, then the name of that circle is circle D. Or conversely, if you're told this is circle D, you know for sure that D is the center of the circle. You cannot assume that D is the center. You would have to be told that explicitly or be able to figure it out in some way. I'm not out to trick you, so don't worry about that being something you have to worry about too much. Just know the center cannot be assumed. Radii, in this circle we have DB, we have DC, we have DA, and you could have called them BD, you could have called them CD, you could have called them AD. We also have our diameter in the circle. The diameter is a segment that connects one point on the circle to the other point on the circle, and it passes to the center. So AC is the diameter that is shown here. There's an infinite number of radii that exist inside the circle. I could draw in many radii, and there's an infinite number that exists. Same thing with the diameter. I could draw in an infinite number of diameters here in that circle. There you go. Area of a circle is pi r squared. So all we need to know is the radius in order to find the area. This will be measured in units squared because it is area. Area is measured in units squared. The perimeter of a circle, also known as the circumference of a circle, is 2 multiplied by pi multiplied by the radius. Keep in mind that the diameter is 2 times the radius, so you might also say the diameter multiplied by pi. And this is measured in units to the power of 1. Here's a theorem we're going to use today and going forward. All radii of the same circle are congruent. So here we have a practice problem, example 1. So if you're watching the video, pause the video now, work example 1. Okay, we're back. A here, find the circumference in terms of pi. Circumference is equal to 2 pi r, right? And so if the radius is equal to 14, then the circumference is equal to 2 times 14 is 28 pi. And I gave you units, so let's record the units, which is centimeters. Circumference is in units to the power of 1, so 28 pi centimeters. It says in terms of pi, so when we're in terms of pi, we don't actually carry out the multiplication with pi. Just have a pi in your answer. If you do ever have to carry out the multiplication with pi, use the pi button on your calculator so that you have the most accurate answer possible. Don't use 3.14. We're never going to use 3.14 in this class. Second problem here, the area. Area is equal to pi multiplied by the radius squared. So the radius is again equal to 14. So the area is equal to pi multiplied by 14 squared. People in class, help me out. What's 14 squared? 196. 196 pi centimeters squared. So there you go. There's the area of that circle as well. Make sure you include your units. If there's no units given, don't worry about writing units to the power of 1 or units squared. You can just give me 28 pi if there were no units given, or give me 196 pi if there were no units given. CPCTC stands for the following. Corresponding parts. Corresponding parts of congruent triangles are congruent. And let's read that a couple more times. So to fully digest something, you need to read it more than once. Corresponding parts of congruent triangles are congruent. And I'll give you an example of this so you can have a handle of what's happening. Corresponding parts of congruent triangles are congruent. So let's say we have two triangles here. Here's one, and I'll just Control C and then Control V it. So those are copied and pasted. So here we have two triangles. Let me actually keep that blue. All right, two triangles, and let's say this is triangle A, B, C, and this is triangle X, Y, Z. All right, and let's say you are given that AB is congruent to XY. You are given that BC is congruent to YZ, and you're given that angle B is congruent to angle Y. Okay, so first off, are these two triangles congruent, yes or no? Yes. They are. By what postulate? Side angle side. So we know for sure that these two triangles are congruent. So if you're given that, and I asked you, how do you know that angle A is congruent to angle X? So how do you know that angle A is congruent to angle X? Well, the two triangles are congruent. Angle A, as we can see, corresponds to angle X. And if you were to write out your triangle congruency statements, you would see that they would be in the same position. But angle A is where the one tick mark side meets the blank side. Angle X is where the one tick mark side meets the blank side. So angle A does correspond to angle X. So the way we know that angle A is congruent to angle X is because corresponding parts of congruent triangles are congruent. This is a reason in a proof. You need to be thinking about that when you use it, but in a proof, CPCTC is a reason. And you don't have to write out all the words. CPCTC is perfectly acceptable. How do we know that AC is congruent to XZ? How do we know that AC is congruent to XZ? We know that because corresponding parts of congruent triangles are congruent, CPCTC. So do you understand how we're going to be using CPCTC? First, we prove the two triangles are congruent, or maybe you're told the two triangles are congruent, and then from there you can conclude that the corresponding parts must also be congruent.
What if you like spell it wrong by accident?
Like if you wrote,
CCPTC.
oh man, I don't think you will. Like you're gonna get that. Here's whenever I write out CPCTC, well first off it's gonna flow off your tongue after a while. You're gonna use it so much, CPCTC, and then also you're thinking to yourself corresponding parts of congruent triangles are congruent. Like it's gonna look weird to you if it's not CPCTC. Your brain latches on this pretty quick. It's kind of like my phone number. My phone number is like, I got the best phone number ever.
For example, I told that. Yeah.
Here, hey, oh, I need to I don't need this on the end. Here we go, example 2. Given circle C, oh, it's my favorite time of the week. The sun shines on me. So that's interesting. All right, here we go. We got circle C here. We know that A is the midpoint of TR. Let's go ahead and mark this up. This is kind of like, not every proof is like this, but these triangle proofs, it kind of helps you out. If A is the midpoint of TR, what can we conclude here? TA has to be congruent to AR. What would that reason be? Definition of midpoint. We're trying to prove that triangle CAT is congruent to triangle CAR. That's the triangle on the left and the triangle on the right. What else do you see about these two triangles? CA is congruent to CA, so that's going to be what property? Reflexive property.
How do you mark that up?
You don't have to. I don't do it. If you want to, you could do this. I'm not a fan of it because there's no match for that one. So like I get to where I see it, and I don't know. But if you want to do that, that's fine. What other thing do you see here? CT is congruent to CR. What is that reason going to be? That's right. It's that reason we just learned. All radii of the same circle are congruent. Do y'all want to try this one on your own now that we've marked it up?
Yes.
Give it a shot.
Do you have to say under CPCTC?
Over here?
Corresponding parts of congruent triangles are congruent.
Yeah, correspond. Yeah, I'll just leave this up here. So go ahead and try that proof out. I'll give you a few minutes, and then we'll come back together as a group. So if you're watching the video, pause the video now. Okay, so we've got circle C that is given to us. Because we have circle C, we know that CT must be a radius and CR must be a radius. CT is congruent to CR. All radii in the same circle are congruent. A is the midpoint of TR. Well, if A is the midpoint of TR, TA has to be congruent to AR. You see that in statement 4. TA is congruent to AR. That's the definition of midpoint. CA is congruent to CA. That's the reflexive property. And then triangle CAT must be congruent to triangle CAR. Side, side, side congruency postulate. If you just write SSS, that's fine by me. If you're going to use side, 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 you don't have to write this off to the side, but you may find it helpful. There's one side, there's one side, and there is one side. If you don't have the 3 sides explicitly written out, you will not receive full credit. So whatever postulate you're using, whether it's side angle side or angle side angle or side side side, each of these letters needs to be reflected in one of these statements up above. Questions on that? Yes, Josh?
We don't need to physically write the S.
You don't have to write what?
We don't have to write the S.
No, this part in blue here, you don't have to do that. Some people find it helpful. Some people it doesn't matter. Okay. Can we go on? Brent, you good?
Yes.
Let's take a look at number 3 here. We have circle O. OP bisects angle TOC. Be careful about what angle is being bisected. Read that a couple times. Sometimes students bisect the wrong angle. Their brain jumps maybe to one angle, but they were told another angle is being bisected, and then they're making conclusions that aren't true. Prove that TP is congruent to CP. Try this one on your own. We'll come back together in a few minutes and see how you did. Here's the approach I think you should take to a problem like this. We have circle O, and I'm trying to prove that TP is congruent to CP. So let's first mark up everything we know and why we know it. We know that TO has to be congruent to OC. We already talked about this because all radii of the same circle are congruent. We know that OP, here is OP, bisects angle TOC. So please be careful here. It is TOC that's being bisected, not TPC. So just be extra careful that you are showing that TOP is congruent to COP. How do we know that TOP is congruent to COP? Definition of bisect. And then OP is shared by both. So that's going to be the reflexive property. I have no information on TP and no information on CP, but if OP is congruent to OP, this top triangle and this bottom triangle are congruent. How do you know they're congruent? Brent?
Is it the CPCTC?
Well, how do you know the two triangles are congruent?
Oh, the side angle.
Side angle side. And if the two triangles are congruent, then we know that TP must be congruent to CP because of CPCTC. Corresponding parts of congruent triangles are congruent. So in the proof, here's what that looks like. First, we have our circle that is given. And I'll mark it up as I go through it now so you can kind of see it. TO is congruent to OC. All radii of the same circle are congruent. TO is congruent to OC. OP bisects angle TOC, that is given. Angle TOP is congruent to angle COP. That angle and that angle, they're congruent. That's the definition of bisect. OP is congruent to OP. That's the reflexive property. And then triangle TOP is congruent to triangle COP. Side angle side congruency postulate. And then finally, TP must be congruent to CP. Corresponding parts of congruent triangles are congruent. CPCTC. I'll leave that up there for a second. I see some folks writing. How are we feeling about that? Good? Is there another one? Oh, no problem. I am. Yeah. If you didn't mark up the figure, you probably need to, and I would also encourage you to write a congruency statement. Here's why. We've got a bunch of angles, and we have to determine what is congruent to what. So if you mark up the figure, you see that RE is congruent to EP, you see that NE is congruent to DE, and of course we have vertical angles occurring here at angle RED and angle PEN. So these two triangles are congruent by side, angle, side. So go ahead and write your triangle congruency statement out in the future if you didn't do it here. This will let you identify what angles are congruent. So R is where the one tick mark side meets the blank side. Well, P is where the one tick mark side meets the blank side. So R and P are corresponding and congruent. So angle R is congruent to angle P, and we have information on both of those. And then also D, we have information on, is where the two tick mark side meets the blank side. Well, N is where the two tick mark side meets the blank side. So angle D is corresponding and congruent to angle N. And we have information on both of those. So you should have said R is congruent to P and D is congruent to N. And by taking these steps, it'll help you not make a mistake in the future. It's pretty clear on this one because of how it looks, but it's not always this clear. So that's a good strategy to use. All right, keep going. All right, once you're finished, the answer is up on the board. Give it a look. If you're at home, thanks for watching. Good luck on the homework.